Hi there, this is Dr. Unbuddy. We're up to Project 10. This project is a game, and it's about classes. It's about using classes, and it's somewhat like last week's lab where we had a card game, and you had a deck class, and you had a card class. This is a different kind of game. This is a checkers game, and if you don't know the game of checkers, then you should find online and play it. But it's sort of like a simplified chess game, like a super simplified chess game. You got a board, you got some pieces, and so on. So we have classes for the board, and then we have classes for the pieces. And it's kind of similar to having a deck of cards, and then the deck and the cards. Now we have a board and the pieces. And so we give you that class because in this project we're using the classes. Next project, Project 11, we'll actually design a class. So it's kind of similar to that one where we use the cards to play the game of war in the lab. So what I'm going to do is talk through some of this, but there's a huge amount of support code that goes along with this. The idea for this one actually came out of one of our TAs, Khalid. He wrote a few hundred lines of code to support this. And the cool thing about it is that when you're done with this project, you will have a program that will use pieces of code that you have written combined with stuff that he wrote to actually do the coming up with the moves, so that you'll make a move and then the computer will think about it and then make its own move. We're going to have a little bit of timing problems with this project, and remember that you will be graded on whether your program works. Some code may time out on mirror, and that makes it inconvenient for you and the TA for that matter. But that does, that's to help you understand whether it worked or not. If it in fact works but takes a little bit longer, that can still be a full credit project, but you just may not have the convenience of having mirror tell you that it is in fact correct. So let's take a look at it. One of the first things you'll see with this project is that there's a lot of stuff there, and let's take a look at some of that. So there's we gave you something to start with, and there's the project, but there are these other things. So like there's the checkers. What's that? That's where we find our board class and our piece class. So you'll want to look at that, and that's just you'll find a lot of similarities between this and the deck and the card class that we had in the lab. Game AI. That's being said as game AI. That's artificial intelligence that we're going to be calling upon when we want the computer to play it. So we don't have to worry about that too much right now. And then the tools are, well, this is just to make your life easier. We've provided you with some functions, and we'll want to take a look at those here in a moment. So the project goes along, and again, you need to figure out how the game actually works. But we do start out with an initial board, and we give you that. And we have a bunch of black and white pieces here to be played with, and so these are black pieces and those are white pieces, and the black ones move this way and the white ones move that way, and they can move in diagonals. So this guy can move here, so there's a valid move. You can't move there. But you can move here. We got to watch out for, yes, there's an end here, and when the white ones have made it all the way to the end, then they can become a king, and we have to worry about that. But like most things, we wait until the end to do that. And then because we save this grid as having indices, they always start at 0, right? And then instead of letters, they also start at 0 and go up. So they go 0, 1, 2, 3, 4, 5, 6, 7, and 0, 1, 2, 3, 4, 5, 6, 7 this way. You know, underneath this is a board that has the indices 0 to 7 in one direction and 0 to 7 in the other direction, and that's part of where we start with this. And let's go down. So there's you'll have to spend some time. How does the game play and so on. How do you move from one place to another? And we get hints. We're gonna have to write all that kind of code. So you want to get a sense of that. I want to go down to the functions that you have to write, and we can start out with this one pair that are called the indexify and the de-indexify. And what this is doing is this is saying, like, okay, I've got the two letters A and 1, and that will be the coordinates 0, 0, or A and 2 gives me the coordinates 0, 1, and then the de-indexify starts with a pair and goes the other way. So you can see here that we are doing things the other way. And what we're doing with this is, if I have a board, then I want to say, oh, this guy, this square here is 0 and 0. And so on. We're translating from the world of the player, who sees this as A1, into the world of the board, which sees that as the origin as 0, 0. And so we have indexify goes one way and de-indexify goes the other way. And those are just, relatively simple functions, and you'll notice that there's no check for a valid position there. So it's a very simple thing. We give you the initialization that prints out the initial board. That is, if you scroll way back here to this thing that starts, there's our initial board. All right? And so we gave you, I decided that we ought to give you that one. Now we start to get interesting. We want to count the pieces on the board. How are we going to do that? Well, what we frequently do is we go and, how do you check whether something, to count the number of pieces on the board? Well, we want to go through and check every single grid spot here and see whether it has a piece in it. So one of the parameters is is the string. It's going to be a black or a white, and so if it's white, I will just march through here. Is there a piece here? No. Is there a piece here? Is there a piece here? And I will go all the way through, and oh, here's a white piece. So if I'm looking for white, I will now say count that as having a white piece. And then I go to the next row and I go through, oh, there we found one. And we go through the whole board that way. So what does that mean? Well, I've got to have a for loop dealing with rows. I got to have another for loop dealing with columns. And then in there, I have to get a piece to look at it, and what will I do? I will have to go into my class, my board class, and there is a get, and I give it a row and a column, and that will give me a piece, like a piece of the piece class, and then I can say, okay, did I actually get a piece, or did I get an indicator that there isn't a piece there? And then I'll do some counting. And so, you know how to count things by now. But we go through all the rows and columns, and then I will get a particular piece. And where do I get this particular method? Well, those are all in checkers. So let's take a look at that. So in checkers, there's a board. And in board, there's things, get the length. So I can get the sides of the board. So if I want to loop through that. And then there's a get. And what does that do? That gets the piece, right? So what's at a particular row and column is a piece. What's a piece? A piece is one of these guys. Right? So that returns a piece, and then I can say, all right, is there actually something there or not? And there are things we can do. Let's see here. So, this returns a row and a cell, and notice that what do things start out at? But they start out at none. And so you can take a look at that and start counting these things. We'll see, where's the count? Here we go. So this is a very nice piece. This is a very nice one to start with. Once you get that working, then you've got a sense of the rows and the columns, and the fact that I go to the board class and get that particular method of the board that gives me a piece, and then I can look at the piece, see if that's a valid piece or not, and then I can count it. Oh, and let's go back here. So what do we know about a piece? Well, look at that. There's a color, so I can get the color of the piece, and then I can tell, all right, if I'm counting whites, then I want to count that or not. Then we get to once we've got that one in hand, then we've got this get all the moves. And what does that mean? Well, we are going to go through this board, and we're going to check to see what all the moves are possible for a particular color. So we've got a board, we've got a color, and then we have this thing about, is this thing sorted or not? And so what I want to do is, again, what I want to try to find all the moves, say, so for example down here, how about all the moves of black? And so I need to go through here, check each one, and go through for every row and column, and so on. So again, we will have, for all my rows and for all my columns, we're going to go through, and here it is. We get there is a black piece. Now where can it move? And notice this black piece, where is it? It is in row C, column 6. Where can I move? And we're going this way. So I can move to this square, which is D5. And so one of the things I will return is this tuple here. I could, if I'm black, I have a valid move to this particular spot, and I can keep going through. Does this guy have any valid moves? Nope. Go back here, go along here. Does this guy have any valid moves? Nope. Keep going. Does this guy have any valid moves? And yep, there's a valid move there. This is at E4. There's E4. It's got a valid move to F5, that guy right there. All right, and so there's a tuple again. Now, How do I find the moves? Well, guess what? We made life easy for you. And we give you a get moves function mentioned here. All right. Well, where's the get moves function? Well, we have a tools, and there's the get moves in there. And so you have to now look at this. There's a nice little description here of what it does, and you will now call that. So when you get, for example, to this spot, when I get to this particular one, how did I know when I was in position C6 that there was a valid move to D5? We get it out of there. And so we will, so we're going to have this for every row, for every column. We are going to have some variable. I'll just make a little box here for it. And it equals tools, because we go into that tools file and we grab the get moves. That is this, and it takes some arguments. I'll let you figure those out, and it will return us something. All right, we'll get the moves, it will return us a bunch of moves, and then from that information I can start to build this list. So because we give you this get moves function, it turns out that this particular one, this particular function is not that hard to write. Or at least it's not as hard to write as it might have been otherwise. Okay, so now that we have all the particular moves, if we choose to do a move, then we have this apply the move, actually make the move. Now, there are some things that, some special things that we have to do. Always leave those to last. What does it mean to make a move? Well, if we have, let me draw a part of our grid here. Suppose I have a black piece here and I want to move it into this square here. Well, if we look in the board class, we have a method in there called remove. So we want to remove it from this spot, and then there's a place to place it in that spot. So what does it mean to move from here to here? Then I have to remove it from this spot and place it in that spot. And that's what happens here, and we get these out of my board class. Once you got that working, then we can talk about raising an exception here, and then we have the thing, what happens if I make it to the last row? These are things that we add on after you've handled the fact that you can move this. We provide a function that sorts the captures. That I put that in there because that allows us to have canonical representation so that we can actually test it in mirror. That's simply for testing with mirror. And then we can move on. Okay, so we had this function up here called get all moves. Now we have one called get all captures, and guess what? There we give you in the tools, we give you a get captures So this one actually looks a lot like the get all the moves, um, and similarly, we had um, an apply move function, and now we have an apply capture. So once you've done the one for moves, you can then do the next two, and similar. We have then we can go and deal with getting hints, and that's that's described there. Getting a winner, we give you specific characteristics of what it means to be a winner, um, and then we give you a main, what's effectively a main, right? And we give you, this is how the human plays, okay? And one of the, and that'll carry you a long way through this project, and then we do this where we actually have the machine is playing, and we give you a description of this, but the big hint here on this that I can say, at first this looks very scary. It's really not, because it turns out that other than the fact that I obviously can't count here, but that this and this are almost exactly the same. There's only a few lines that are different in there, and that's what your challenge is. So to create the AI one, what I did is I actually just copied this function, and then I made some modifications to it. So think about this not as, oh, I got to write this whole thing, but it's like, all right, we already have gameplay. Now I just have the gameplay to change a little bit to use some things out of the game AI. And that's what your challenge is. How do I make the few changes to make that work? And they aren't large. So when you look at this part of it, think of this as, oh yeah, there's something small I need to do to make this work, right? As opposed to, oh my goodness, it's going to be really complicated. No, because we give you this game AI, then it turns out that it's relatively small. And if you didn't hear me saying that just now, only I say there only a few lines are different, and I give you some ideas on where to look. So the challenge of this project is coming to grips with all the support material that we gave you. Right? It's similar in many respects to the last couple, like say Project 9 or even Project 8, where you had to wrap your head around a data structure, and then once you got your head wrapped around how do I build this dictionary, you could then put together the rest of the project, in a way that you're somewhat comfortable with from the previous projects. And this is similar in that sense. Once you get your head wrapped around the tools and the classes that we provide, putting together the code is no more difficult than what you've done before. Really the challenge is to get your head wrapped around this. So hopefully that gives you enough. Good luck with it.